Let's face it, we are not designing electronic systems in a vacuum. Well, I guess unless you are designing a vacuum. But for the rest of us, non-vacuum designing embedded engineers, making sure that each part of the ecosystem, all of the accessories, disposable elements, and add-ons of our embedded design lives up to the standards of the original design itself is crucial. And one critical element of these embedded system ecosystems is security. But how do we keep costs down and the form factor small enough for these kind of disposable and accessory ecosystems? Cost-optimized, secure authentication ICs from Microchip. That's how. Hi, I'm Amelia Dalton, host of Chalk Talk. Secure authentication for disposable and accessory ecosystems is a critical element for many embedded systems today. In this episode of Chalk Talk, Xavier Bignalet from Microchip and I explore the benefits of Microchip's Trust Platform Design Suite and how it can provide the security you need for your next embedded design. We investigate the value of symmetric authentication and asymmetric authentication and the roles that parasitic power and package size play in these kind of designs. And before we get started, don't forget to click that link. There you can find even more information about this topic from Microchip. Hi, Xavier. Thank you so much for joining me today.
Thanks for having me. That's a fantastic opportunity to present to the embedded community.
Excellent. Okay, so we're talking about secure authentication ICs for accessory and disposable ecosystems today. But before we get started, can you set the stage for us? Why do we need this kind of authentication for these types of systems?
Yeah, so in the embedded space, there are several reasons why you want to have secure authentication at cost-optimized price point. It really rotates against the user experience and controlling an ecosystem of things. So that's where the accessory and the disposable come around. Let me give you an example for the user experience of the keyboard hooked up to the tablet, right? As you type on your keyboard, you have a certain speed at which you type, and the frequency at which you type is not what you're actually typing for. You're going to be having a frustrating user experience. So authenticating your keyboard to make sure it's doing what it's supposed to do from the provider that's selling that keyboard, it will involve authentication. You can apply that example to many different applications. So user experience is one thing, controlling the ecosystem as you grow beyond the keyboard, to keep the tablet example. You imagine you have a mouse, AR, VR, accessories, and so forth. So you have a branded ecosystem that grows, and maybe you welcome third party into this ecosystem that you want to control to make sure they provide the same or better user experience that's attached to your brand image, right? Now we talk about reputation immediately. There's something else. There is counterfeit protection also. When a brand is successful and they're driving volumes, they're going to be looked at by counterfeiters because they want a share of your pie, essentially. So those are the main reason why you want to have authentication for accessory disposables.
Okay, so when it comes to these kind of ecosystems, what kind of products or markets are we talking about?
We see it virtually everywhere. One of the segments that really benefits from it is the medical segment. And the disposable side of the business is really also coming from that. If you think about breathing tube, cables, sensors, cartridges with medicine/patches, those are the things you look at authentication for. You also have the consumer market, classic, the good old printer cartridge business model, using the type of technology for a long time, but that's all business. There are new businesses in the world of fragrance, Qi wireless charging. So that's when you wireless charge your phone from those Qi chargers. That's another space. The industrial segment, where it's a lot about third-party ecosystem control there, but also maintenance service. So imagine you come and replace your electronic car into an elevator. Before you call the maintenance service, they're going to check if the replacement board is legitimate. Then the maintenance service will be able to install it with confidence. And then you can honestly tie that to warranty or service, right? Automotive, e-mobility, data center are three other segments Most of them are reflecting the similar cases. Data centers, the control of third-party contributor into the data center ecosystem, data center being extremely sensitive. You want to control that. And there is actually a standard that starts to mandate that type of authentication to be used. E-mobility, automotive, again, with electrification of the vehicle, the amount of electronic cards that play into the cards is growing. So as those electronic cards, those ECUs run more and more safety critical operations, you probably want to authenticate those cards or what goes through those cards, the messages that are critical to go through those cards. Imagine they start to control the powertrain and that gets altered. You don't really want that. Chip wireless charging also is pretty huge in automotive. So those are the type of example we'll see.
Excellent. So, Xavier, how can Microchip help me here?
On the security portfolio, we have different standalone ICs as well as microcontrollers with security features and microprocessor and FPGAs. At the standalone IC level, we have 4 lines. We have the crypto authentication, crypto automotive. The TPM is an historical product line, the trusted platform module. And then we have the platform root of trust. Right now, for this specific marketplace, application place, the accessory, disposable, ecosystem, control type of thing, we will focus on the crypto authentication and crypto automotive lines. If we continue a little bit further in details and look at how the portfolio looks like, we have a series of secure element and platform root of trust. We start from left to right with the SHA-106, SHA-104. Those devices have been in the market for more than 10 years. 8608, we launched it in 2017, I believe. And that has been one of the hero products for that space. But what we learned from our customers, they wanted to have a subset of this 8608 or SHA-204. And that's where we came up with the Tier 10, EC204, EC206, SHA-104, 5, and 6. The Tier 10 will address the automotive segment because you want to have an automotive qualified part. The Tier 10 will give you that all the way up to grade 1 qualification. On the accessory disposable space here, the C204, C206 will give you asymmetric authentication, and the SHA-104, 5, and 6 will give you symmetric authentication, essentially. There's a trick to the C204, it gives you actually an HMAC on top of the asymmetric authentication. Note something, the last digit on those part numbers, when there is a 6 at the end, essentially we start to integrate the notion of parasitic power. If we focus on the value of those solutions, there is another value beyond the cryptographic algorithm, the secure key storage. There is also the notion of package. So what does package matter? Because as soon as you get into the world of disposable, form factors matter, size matter, right? So if we start with the Tier 100 in the automotive space, it's a superset of cryptographic features. It's got RSA, 2K, and so forth, and a lot more cryptographic algorithm there. We need a cut down version of it. That's where the Tier 10 comes in. The Tier 10 will give you a CDSSI and an HMAC. ACC 204 will give you a subset of what EC 608 has been giving you, meaning the EC 204 will come up in UDFN8, SOIC8, and 3-pin, we call it RBH package. That's what the EC 204 will come up with. And it'll give you similar algorithm, ECDSSI, no verifies, and the HMAC. Then if we move on to the SHA-105, the SHA-105 is your host secure element, and SHA-104 is your client secure element. You can use both, you don't have to. Your threat model will steer you in the right direction in terms of the usage of one or both of those two secure elements there. What those devices, SHA-104 and 5, as well as the 6, will give you, it's a MAC, essentially, a message authentication code. This SHA-105 will give you a check MAC to verify the MAC. So then you have the EC206 and the SHA-106, which are coming under the form factor of a 2-pin device where we integrated a capacitor to create that parasitic power. Parasitic power is when you load enough energy to run the crypto operation inside the secure element and give you an output. That type of form factor is particularly interesting because it allows you to eliminate the printed circuit board, the PCB, in the disposable and reduce the associated costs with it. So the only thing you'll do is glue that 2-pin package or the 3-pin package into your disposable and come up with metallic contact into the secure element to run the authentication.
Okay, so Xavier, in previous Chalk Talks, we've talked about symmetric authentication and asymmetric authentication in this context. But for my audience who may not know, can you explain each of these approaches and how they differ?
Yeah, absolutely. So in the world of symmetric authentication, the foundational notion is your symmetric key is the same on the host and the client. So imagine your monitoring display and the medical sensors. The problem with that, if you get one, you get all of the sensors. You get a problem. So you want to store that key on both sides, call that symmetric authentication. What will happen essentially, the host, or in that instance, the display, the monitoring display will send a challenge, the disposable, that will run a SHA-256 algorithm to output a response. The response is your message authentication code, that's your MAC. The MAC goes back to the display. And in the meantime, display would have done the same thing. It would have run a SHA-256 algorithm to give you the response, which is a MAC, and compare the MAC. And if they're the same, the monitoring display will accept the information coming from the sensor, the disposable. There are other techniques of symmetric authentication that are out there. So this is the most basic one. You do have to protect the key on both sides with SHA-105 on the host, SHA-104 on the client. But better architecture, we talk about diversified key. That's probably a more evolved technique, which we do provide code examples for. That would probably be more recommendable than the symmetric authentication.
Okay, so what about asymmetric authentication? What steps does this solution include?
So asymmetric authentication differs quite a bit from symmetry because now you don't have two keys of the same kind. They are actually two keys, but they are different and yet mathematically related. That's where the notion of algorithm comes in to calculate the public key out of the private key. So we have classes on Microchip University. If you look at the cryptographic primer on Microchip University, we'll go into the deep details of those two notions there, symmetric and asymmetric. But when it concerns us, essentially, you're going to have a chain of certificate linking the different layers of authority that each correspond to. So if you go through this diagram, we're going to have the highest authority called as the root authority. So that's where you have the root public key. The associated private key is protected in HSM of the customer. And that is what's going to verify what comes in from the accessory, the disposable. So here the signature and the public key are presented from the accessory into the host and verified by the public key. And we do the same thing at the level underneath it with the signer public key. So the signer public key was provided by the accessory, verified by the root. And we use that now that we trust that to verify the device level. So that's the lowest level of the chain. The device public key is verified along with the signature. Once you have that, so you trust the root, trust the signer, you're going to trust the device certificate. Now you're going to tell your host to send a challenge to the accessory and say, hey, sign me with your private key. That private key is, we call that the prima donna of security. It's the most important credentials you have in your system, because that's what gives the identity of your embedded device to that system. So out of that ECDSS sign with the private device private key, you get a signature that will be verified along with the sign challenge. If that verification is successful, then the accessory, the disposable, is authorized to operate in the ecosystem.
So, can we also talk about that parasitic power you mentioned? Can you give me some more details about that?
Yeah, let's take a deeper look at it. Essentially, the secret is integrating a capacitor inside that two-pin package, which is 2x2, 0.35 millimeter. And you reduce the number of pins, you make the package extremely small, you eliminate the need for a PCB inside the disposable accessories. It helps you to reduce the system level cost because you don't have to solder down a part on the PCB, so the PCB is the added cost, and extra component that would be needed on the PCB on top of your secure authentication IC there. From a technical standpoint, you also remove that extra pin that the supply would be, because you can run the supply and the communication on the same pin. So that's one less pin to worry about. And that's the whole secret. It's all around that integrated capacitor.
Okay, so Xavier, what other solutions could we look at to address these issues?
Let's take a look at the variety of packages we can offer. So we have the standard packages, right? The UDF-N8, SOICH, just very, very standard packages that the embedded industry knows of. And then we have those more application-specific packages, the 3-pin, the 2-pin that we just talked about, but also Microchip has the capability to offer WCLSP. You would have to contact Microchip sales to get the CLSP. If you look at the 2-pin versus 3-pin and focus on just those two, both the SHA-104 and EC204 supported in 3-pin. SHA-106 and EC206 are what the 2-pin package is. Do you have parasitic power in the 3-pin form factor? No, you don't have that capacitor. It's only in the 2-pin form factor. In either cases, two-pin versus two-pin, that's what allows you to eliminate the PCB. Do you need an external cap if you want to run parasitic power on a three-pin? Yes. So now you have to figure out where you have to have this external capacitor. Can it live on the host side of the embedded system? If yes, you can still live without a PCB.
So, Xavier, what would these kind of designs look like in the real world?
So in the real world, we talked about secure key storage, cryptographic accelerator, and those secure authentication devices. To operate them, you're going to have to load a key, to provision a key or multiple keys right inside those devices. How do you do this? You're going to have to go through something called a secure key provisioning service. That's where Microchip established a tunnel of trust between our factories where our hardware security module are operated, and they sit next to our testers in our factory. Those HSM are in 24/7 monitored rooms, so they have dedicated room for the HSM. That's required to get a security certification we have in our manufacturing process. So how do we bind those HSM to our customer? There is something called a secret exchange that binds the customer with our HSM. And now we're able to start to provision keys into the device. The beauty of the system is we've architected it to make sure it scales from very small project down to hundreds of units, all the way up to billions of units. That's what we've been investing throughout the years.
Okay, so what kind of supporting materials or evaluation boards do you guys have when it comes to the Trust Platform Design Suite?
Right. So to get into that secure key provisioning service that Microchip offers, how do you get started? So this is how you get started. First thing you want to do is download this software called the Trust Platform Design Suite. It's available on our website. If you do microchip.com/trust platform, you'll find the right page there. Once you have the software installed, you also want MPLab. In the tutorial of the Trust Platform Design Suite, we're guiding you on how to connect the MPLab to the Trust Platform Design Suite. But you also need hardware development kits, right? And that's all the pictures you see in the slide here. We have, depending on the type of device, you can get an add-on board to that DM32018. That's your base board, essentially, where you're going to plug the add-ons. Or you have a socket version, 2-pin, 3-pin, UDFN, SOIC8, that you can come and plug on the base board there. So you get your hardware, you get your Trust Platform Design Suite software. And then what else do you need? You're going to need code example. The code example are within the Trust Platform Design Suite to operate. Once you have your code example up and running, thanks to TPDS and the hardware, you want to go to production. That's where you're going to need the configurators to configure the memory of the secure element, but also provide the adequate files to Microchip to move your secure element configured and provisioned via our secure provisioning service. So you get everything right in your hand if you use the Trust Platform Design Suite. And that's how we get you started.
Excellent. Now, Xavier, can you recap your main points for me? What would you like my audience to keep in mind here?
All right. So the big thing we keep on investing on at Microchip is lowering the barrier of entry into using security technology overall. The Trust Platform and the Trust Platform Design Suite software are massive contributors to that. We also updated the architecture of our silicon devices to make them even more cost efficient than what they were before, right? To get those type of cost sensitive application that the world of accessory and disposable are requiring. And we want to enable that without slowing down the development, right? So that's why we have the tools, the Trust Platform Design Suite again. We also enable this whole technology via our e-commerce stores along with our distribution partners. And as we do this, we're going to make sure the minimum orderable quantity are low, that everybody can benefit from that type of technologies. There are requirements demanding that type of technology. It's been challenging throughout the years to get it overall beyond Microchip. Microchip has been spending years to optimize the flow to make sure the low MOQ are available. And finally, you have the famous crypto-auth-lib library. That's what keeps your microcontroller completely agnostic of that type of technologies. So those are the big takeaways I would like the audience to leave us with.
Excellent. Well, Xavier, I think that's all I have time for today. Thank you so much for joining me.
You are most welcome.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Microchip. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.